In this video, we're asked to write a method called construct. It'll accept the parameter of a sorted array of integers, and it'll construct a balanced binary tree of those integers. So the tree should be constructed so that every node, either the left and subtrees have the same number of nodes, or the left subtree has one more than the right. So for example, we have a tree called T, and we call upon construct with the values in this array 1, 2, 3, 4, 5, 6, and 7. Then we should get the resultant tree here. But if we have the array 3, 8, 19, 27, 34, 42, so forth to 74, we do see that there is an additional node on the left-hand side, on the left-hand subtree than the right-hand subtree. Yeah, okay. So I mentioned that. Yep. The new tree will replace the old tree. Anything else? Nope, that's it with the spec there. So let's get started. So we're going to replace the old tree, and the way we do that is by using the xChangeX method here. So we're not going to return a new tree because we're just modifying the old one. We're going to take in an array of integers. We're going to call it data. This is where we're actually going to start modifying the tree. Overall root construct, the data value. What else do we want? We want to know when to start constructing this thing, and we want to know when to end it. So the way we're going to say we're going to end this construction method is when we've reached the data.length. We've reached its last point. So this will say, okay, let's loop through the entire array here, and while we're less than the very last value of the array, let's keep constructing. So I will go to a private method. It's going to return int tree node because we're modifying the overall root. Construct, so the array of data integers, the starting point of when we start looking at the array, and then the ending point of when we want to finish looking at the array. So let's get started here. So what happens if the start is greater than the end for some reason? Like say that there's no value, that it's just an empty array. Well, at that point, we know that we just want to, oops, kind of gave away the answer by typing that there. We just want to return null. We have no values in the tree. We have nothing to look at. We can't construct a new tree. But we can replace the old one with just an empty tree. So how are we going to get the middle value? Well, the way we're going to do that is we're going to say, so for example, let's say that there are 4 elements in the array. The way we're going to do that is we're going to say, we're going to get the middle element by saying, okay, 4 divided by 2. But in this case, because we're dealing with zero-based indexing, what we need to do is we need to say, we need to have a 1, then plus the start value, plus the end value, and then divide that all by 2, all because of the zero-based indexing. And mid needs to be equivalent to that. That'll grab us the middle range. So what we're going to do is we're going to construct a new int tree node at this point. And what we're going to do is we're going to grab the middle data in the array at that point. And then our new start method is going to be equivalent to a construct of the data with the start, and this will construct the left subtree. And we want to get we want to stop at the points up until up to 1 minus the mid, or 1 before the mid. And then the ending is going to be, okay, a calling on construct data. It's going to be mid plus 1 is going to be a starting point because we're excluding the minimum here, or I mean the mid range here, and the minimums. And our stopping point will be at the end. And that'll be it for this video.